Good evening, my dear 9th standard students. In the previous lecture, we have discussed the equations of motion for a body moving along a straight line with uniform acceleration, that is rectilinear motion. So, the three equations of motion, do you remember? Can you tell me the first equation? Yes, V equal to U plus AT. Yes, you tell me the second equation. Very good. S is equal to UT plus half AT square. And the third one, okay, you try. Yes, it is V square is equal to U square plus 2AS. So these three equations we derived in the previous class by analytical method, by mathematical method. Today the same three equations of motion we are going to derive by graphical method. And you look at the topic of today's discussion. These are the equations of motion for a body moving with uniform acceleration along a straight line. So by graphical method we are going to derive today. What is the first relation called as the velocity time relation? Okay. And what is the relation just now you said? V equal to U plus AT. Shall we derive this by graphical method? Good. Now look at this graph. Drawn between velocity taken along the y-axis and the time taken along the x-axis. The SI unit of velocity is meter per second and the SI unit of time taken is seconds. So, what is the shape of the graph? You look at the graph. This blue line is the graph actually. The initial point of the graph is A and the final point of the body is what? B. AB is the actual graph. Okay. Now, it is a straight line. Is the straight line passing through the origin, you tell me? Of course, no. Good. That means when the graph does not pass through the origin, means can the body start with zero velocity? No. Perfectly? No. Good. That means the body has started already with an initial velocity. So, which portion of this graph represents the initial and final velocities? Let us see that. So, the point A lies above the origin. So, this portion OA must be equal to the initial velocity of the body, that is represented by U. And the final point B, okay, is projected on the x-axis at C. Okay. So, this vertical length BC must be equal to the final velocity of the body V. Did you understand the graph first of all? Okay. What type of graph it is? It is velocity versus time graph. So, velocity is taken along the y-axis and time is taken along the x-axis. Okay, good. Now, some geometrical constructions we are going to consider. First one is, you look here, draw AD parallel to OC. So, you can see that the dotted line is AD. Is it drawn parallel to OC? Okay, good. So, they are equal in length. Then, what is the second construction we have done? Project the point B. Project B on the x-axis. At which point is C. So, B is vertically projected on the x-axis and it is meeting the x-axis at the point C. Okay. So, you look at this length OA. The length OA is equal to U. So, that is equal to the initial velocity of the body. And what is BC here from the graph? What is BC equal to? Look at this graph. BC, that is equal to V, the final velocity of the body. Okay. Then this length of the portion OC, the length of the portion OC must be equal to T, the time taken by the body. Understand? So thoroughly you should understand before doing the derivation. So the length OA is equal to U, the initial velocity of the body. The length BC is equal to V, the final velocity of the body. And the length OC is equal to T, the time taken by the body. Understand? Okay. Now, from the graph, you look at this straight line BC. This BC can also be written as the sum of the two sides BD and CD. I have written BC. The total length BC is equal to this portion, smaller portion BD plus the remaining portion CD. And this CD is parallel to OA. So, can I also substitute OA in place of CD? Yes. Good. Have you understood? Okay then. So BC can also be written as the sum of what BD and the OA. Okay. But already you see that BC is equal to what? The final velocity of the body V. So instead of BC I have substituted V, and instead of OA I have substituted U. Therefore V is equal to this BD plus U, or BD alone is equal to what? V minus U. So V is the final velocity and U is the initial velocity. So this is equal to final velocity minus initial velocity, and that is equal to the change in velocity of the body. Up to this step, are you understanding or not? Good. So the length BD in this graph must be equal to what? The change in velocity of the body. And this change in velocity has taken place in how much time? Good. In a time equal to t seconds. So how to find the acceleration of the body? Yes, how did we define acceleration of the body in the previous class? It is defined as the rate of change of velocity. So acceleration A must be equal to what? Change in velocity by time taken. And in this graph, the change in velocity is represented by which portion? It is represented by which portion? BD. Okay. So this must be equal to BD divided by time taken is that is OC. The portion in the graph which represents the time taken is OC. So instead of BD I have substituted V minus U, and instead of OC I have substituted the time taken T. Therefore A equal to V minus U by T. Shift this T to the left side. It will become A into T. AT is equal to V minus U. And shift this minus U from the right side to the left side. It will become AT plus U equal to V. Now you rearrange, you will get the equation what? V equal to U plus AT. So this equation V equal to U plus AT is the first equation of motion, and it is also called as velocity time relation. I hope you all must have understood. Shall we go to the second equation of motion? That's good. Okay students, now let us derive the second equation of motion, which is called as position time relation. It is given by S equal to ut plus half at square. Look at the graph once again. It is a graph drawn by taking velocity along the y-axis and time along the x-axis. It is a VT graph, and the nature of the graph is a straight line AB, and A is the initial point, B is the final point. I have projected the initial point A at O, and the final point B is projected at C, so that the closed portion below the graph is appearing like a trapezium. Can you look at the trapezium O, A, B, D, C? Okay, good. Now the velocity time graph has two importances. One is its slope, the other one is its area. The slope of the velocity time graph is equal to the acceleration of the body. Already we have used the concept. And the area under this velocity time graph must be equal to the distance traveled by the body. Okay students, now you look at the derivation. The distance traveled by the body is equal to area under the velocity time graph, and it is equal to the area of the portion OABC, and that is equal to area of the trapezium. I told you that this OABC is a trapezium. This can also be written as equal to what? Area of the rectangle OADC plus area of the triangle ABD. So where are these two? Let us see. OADC. OADC. This is a rectangle, and ABD is a triangle. So we want to add the area of the rectangle and the triangle. Now before that, in the graph, what is this length of the portion OA must be equal to? Yes, that is equal to initial velocity of the body, U. So I have written OA is equal to U. And you tell me what should be the length of the portion OC is equal to? Yes, the time taken by the body. So I have written what? OC is equal to T. So OA is equal to U and OC is equal to T. Therefore, what should the area of the rectangle OADC must be equal to? OA into OC. This OA into OC, that is equal to U into T. Have you understood this first? Shall I proceed? Okay, good. So area of the rectangle is equal to U into T. Now we come to find the area of the triangle. So area of the triangle ABD. ABD. And what is the formula used to find this? Half into base into its height. So this is equal to half into base of the triangle is equal to AD. I have written AD. And height of this triangle is equal to what? BD. That is substituted as half into, instead of AD, we can also substitute OC. So AD is parallel to OC. Therefore, I can substitute OC in terms of AD. And already we have found that this portion BD is what? The final velocity V minus initial velocity U. So this half into OC into BD can be written as half into T instead of OC and V minus U instead of BD. Okay. So the area of the triangle ABD is now equal to what? Half into T into V minus U. But from the definition of acceleration, A equal to V minus U by T. Therefore, V minus U is also equal to what? A into T. Is it not? Therefore, the area now is equal to what? Half into T into AT. Instead of V minus U, I can substitute AT. So, this AT into T is AT square. Into half will make it as half AT square. Have you all understood? Yes. So, the distance travelled is given by S equal to area of the rectangle OADC plus area of triangle ABD. So, we have to add a UT with half AT square. Therefore, S is equal to what? UT plus half AT square. Yes, I hope you must have understood. Shall we go to the next equation? That's good. Okay, now let us derive the third equation of motion, which is called as the position versus velocity relation, that is given by V square equal to U square plus 2AS with reference to the same graph. What is the name of this graph, you tell me? Yes, velocity time graph. What is the shape of the graph? Straight line. Okay, good. So projecting the point A at O and B at C, the closed portion appears to be a trapezium, and the area under this velocity time graph must be equal to what? The distance travelled by the body. Just now we have seen the same concept in the previous equation. The distance travelled by the body is given by S equal to area of the trapezium. Now in the previous derivation, the trapezium was combined as what? A triangle and a rectangle. Is there any formula to find the area of the trapezium directly? Can anyone tell me? Yes, it is half height into sum of the parallel sides. So this is half into height, vertical height, and into sum of the parallel sides. So this is equal to half into the vertical height is equal to AD or OC. So OC is the vertical height between the parallel sides. And what are the two parallel sides? One is OA, the other one is BC. So OA plus BC. Okay. So S must be equal to half into OC into OA plus BC. But what is the length OC is equal to? That is equal to the time taken T. And the portion OA is equal to what? The initial velocity U. And the portion BC and its height is equal to what? The final velocity of the body equal to V. We are going to substitute in the previous equation. Therefore, now S is equal to what? Half into, instead of OC, substitute T into, instead of OA, you substitute what? U plus V. Okay. Then it can also be written as V plus U. So S is equal to half into T into V plus U. Okay. Now, what is the expression for acceleration we have derived earlier? A is equal to what? V minus U by T. Okay. Now shift, interchange by shifting T to the left hand side and bringing A to the right hand side. This can also be written as what? T is equal to V minus U by A. So, in this expression for the distance travelled S, in place of T, I can substitute V minus U by A. So, this equation now can be rewritten as S is equal to half into V minus U by A. Instead of T, I am substituting V minus U by A. There is no other change here. Into, the next term is what? V plus U. This is a V plus U. So, rearranging this, it can be written as S is equal to 1 divided by 2A. This 2 into A will become 2A in the denominator. Into, this is of the form A minus B into A plus B. That is equal to what? A square minus B square form. So, this is also equal to 1 by 2A into V square minus u square. Cross multiplying, the left hand side becomes 2a into s, 2a into s, and the right hand side is equal to what? B square minus u square. Then bring this minus u square to the left hand side, it will become what? Plus u square. So u square plus 2as is equal to b square, and rearranging this, what we can get? B square is equal to u square plus 2as. Is it easy? Have you understood? All the three equations of motion, have you understood? Yes. Let us summarize the three equations of motion which we have just derived by graphical method. Yes, what is the first equation of motion? Good. V equal to u plus at. And the second equation of motion is what? S equal to ut plus half at square. And what is the third equation of motion just we have derived is? V square equal to u square plus 2as. Okay students, after this I will give you a summary of that set of equations for bodies which are falling downwards and moving upwards. Okay, let us write. My dear students, have you heard that gravitational force was invented by Isaac Newton from the falling apple? Yes, that is a familiar story which you all have heard in the lower classes. So why the apple is always falling in the downward direction was investigated by Newton, and finally he concluded that it was due to the gravitational force, and this force pulls all the falling objects towards the center of the earth. So while these objects are falling towards the center of the earth, their velocity will be continuously increasing. As a result, they will all gain an acceleration, and this acceleration gained by the body on account of the gravitational force only is called as what? Acceleration due to gravity. Let us now define this term, acceleration due to gravity, and this is denoted by the symbol small g. So it is defined as what? Acceleration gained by a body due to the gravitational force exerted by the earth, and its value is given by g equal to 9.8 meters per second square. So imagine a huge rock is falling and a very small cotton ball is falling in the downward direction. Irrespective of their sizes, irrespective of their nature, irrespective of their masses, both will have the same acceleration. So it will be humorously given in some books that an ant and an elephant falling in the downward direction will have the same acceleration. So keep it in our mind, it is the constant for all bodies irrespective of their masses. Okay. And its value is how much? 9.8 meter per second square. So we are going to rewrite the set of equations of motion for different bodies. First one is the equations of motion for a body moving in the downward direction. So whenever the bodies are falling in the downward direction, they are falling along the direction of the gravitational force, and hence their acceleration is equal to positive, that is plus g. And the first equation is v equal to u plus gt. The second equation is s equal to ut plus half gt square. And the third equation is v square is equal to u square plus 2gs. So we have replaced the term a by the term g. Otherwise the same set of equations only we have written. Now the second set of equations are for a body moving in the upward direction. Suppose if an object is thrown up, as it is going higher and higher, its velocity is continuously decreasing, and when it reaches the highest point, momentarily it stops with the final velocity 0, and then it will return. Anyhow, while it is going in the upward direction, its velocity is continuously decreasing, so its acceleration will be negative. Therefore, a must be equal to what? Minus of g. So the same three equations are rewritten like this. The first equation is v equal to u minus gt. The second equation is s equal to ut minus half gt square. What is the third equation? Yes, v square is equal to u square minus 2gs. Yes, is it easy? Are you understanding? That's good. Now the third set of equations, especially for freely falling bodies. Freely falling. Suppose you take this pen is in my hand. So long as it is in my hand, it is not moving. The moment I drop, it starts to move. So before it starts to move, when it was in my hand, it was at rest. So what should be its initial velocity? Yes, good. That is 0. So for all freely falling bodies, you have to assume the initial velocity is equal to 0. So in this set of equations, V, S and V square. You have to substitute what? U equal to 0. So the first term U is equal to 0. Therefore, what should be the first equation for the freely falling body? It is moving in the downward direction. Okay? And hence its acceleration is positive. That is plus G. But U equal to what? 0. Yes. You tell me the first equation what it must be? V equal to, yes, it is actually U plus GT, but since U is equal to 0, we get V equal to GT. And the second equation is what? S equal to half GT square. And the third equation is what? V square is equal to 2GS. So all these equations are very important for solving the numerical problems. So what is my advice to you all, dear students? Practice makes a man perfect. So all these graphical derivations and the set of equations of motion, you have to write again and again and practice till you become a master of that. So wish you good luck. In the next video, I will be meeting you in solving the numerical problems. Before that, you practice these graphical derivations and the equations well. See you. Bye.